Welcome back to the generic crafting tutorial series. In this fifth episode, we're going to be going over the inventory component and setting up all of the basic values for this. This will be another bit of a long episode, so do try to stick with me as we go through here. So in some of the last videos, we actually put the inventory folder with the structure for inventory info inside of our player. This doesn't need to be here. We actually need to move this up into the generic crafting, into a new folder. And I'm just going to call this blueprints. You could call it inventory or whatever you want. But inventory is not limited to just the player, so it doesn't make sense for it to be in the player folder here. So we're going to move that up into blueprints. There we go. So now that we've moved that over to blueprints, we have our inventory folder in here. So we're going to make a new blueprint class in here. This is going to be of the type actor component. And this is going to be AC inventory. And this actor component, we're making this an actor component so that it can be used on multiple different classes. So we're going to use this on our player, we're going to use this on our vendors, we're going to use this on our storage items. So when we open this up, we don't really need anything in this event begin play yet. Compile, save. We're going to need some setup variables that are going to determine a lot of values for the player or for the storage container. And all that stuff. So let's go ahead and set up our variables first. The first thing we're going to need is inventory size. This is going to be an integer. And this is going to be how many items the inventory can hold. We're going to need another variable called BUseInventory size. And this is going to determine whether or not the actor that is holding on to this component actually uses inventory size. So for vendors, this is going to be false. For the player, this is going to be true. Or false if you maybe want infinite inventory size on your player. Totally up to you, but we're going to need this boolean. We're also going to need another one called BUseOverflow. Now I'll explain this later on, but this is for overflow logic, so maybe we don't have them in this tutorial series, but maybe you have items being dropped or spawned into the world, like you defeat an enemy, it drops a loot pickup, and when the player walks over it, they automatically pick it up. Well, maybe you want to have a place for that to go when the player's inventory is full. That's where we're going to use this BUseOverflow. So it's not exactly 100% needed for this tutorial series, but it is something that I've added in here that hopefully you'll end up using. So we're going to make all three of these instance and exposed. These are very important because these are the setup values that everything is going to need to set up. We're also going to make them on the category setup. And again, this is all going to have to be set up on each actor that inherits this component. Okay, we need another one here. This is not going to be set up. This is going to be inventory content. If I can type. Of the type S inventory info that we made in one of the previous videos. And this is going to be an array. By the way, I will link another tutorial series in here that does inventory slightly differently. Ryan Laley's tutorial series. I think is pretty good, especially for beginners who don't understand inventory at all. Mine is going to be a little more advanced than that and work in a significantly different way altogether. But I think his inventory tutorial is probably a good place for you to get started compared to mine, which is going to be a little more complicated. We're going to give this the category inventory. And we're going to duplicate that and make that inventory overflow. Hopefully I spelled this stuff right. So that's not actually going to do really anything on our player. This is actually going to be held on our banker, and it's going to handle the overflow. But we'll get to that when we get to it later on. It's a bit complicated there. We have one more for now called currency. And we'll be adding in equipment later on when we make that. We're just going to add currency into the category of currency. Now, we might not use this today, but we will be using this in the future. So we have inventory size, B, a boolean for use inventory size, a boolean for use overflow, and those are all going to be instance, exposed, and in the setup category. We're going to have a structure of our custom, or an array of our custom structure for inventory info. It's going to be our inventory content and our inventory overflow. Now we're going to have our currency value, which is just going to be the amount of money that the player has. So let's get started with adding an item to our inventory. Again, like I mentioned, this is Ryan's tutorial series is probably a bit better at explaining how all of this stuff properly works. But we're going to be doing basically the same thing as him for a couple of these base level functions like add and remove from inventory. We're just going to be doing it all at once instead of a bunch of different stuff. So add to inventory. This is going to be a function. We're going to add this into a category called AddItem. So we're going to have a lot of functions inside of this actor component. So we want to make sure that they stay nice and neat. We're going to have an input value here of item info. And that is going to be that structure of inventory info. Whoops. I'm going to break that open. We're going to take our quantity and promote our quantity to a local variable called L. Amount. I don't feel like spelling quantity. Local amount, local quantity, whatever you want to call it. Doesn't really matter too much. Or local remaining. Let's call it remaining. Remaining's a little bit easier to understand. We'll get that local remaining. We'll see if it's greater than 0. And we're going to need another local variable here. This is called a B or L fail. And that's because we're going to be running a while loop. While loops kind of need two variables to basically prevent infinite loops. So we're going to need a fail out. So a way to fail out of the while loop so that we don't end up with infinite loops. I usually don't like using while loops. I wasn't going to use one for this. But honestly, it's just a little bit easier when you're dealing with a lot of items. Not branch. It's a little bit easier when you're dealing with a lot of items. And we are going to be dealing with a lot of items. So let's say we're adding 100 items of this item ID into our inventory. This while loop is going to make sure that it kind of flows through and caps up all of the... Like if we're adding 100 or 10 iron ore, if we already have a stack of 98 iron ore and our max stack size is 99, it'll add 1 to that 98 and then make a new stack for it, as opposed to just trying to kind of add these in based on quantities with for each loops. You know, I did have one that used for each loops and it was like that long. So a little bit easier to just use a while loop here and make sure we have a local fail to fail out of the while loop. So we're going to have to do a few different things for this loop body to make sure that we are adding the inventory in properly. We're going to need a couple of custom functions. So we're going to add a new one called find slot with space. It's also going to be part of add item. And in a find slot with space, we are going to need an input and an output. So we're going to add output and input. Input is going to be the same inventory type info. So this is going to be item info again, because we're just going to pass that inventory type info straight in here. And our output's going to be an integer called index, or array index if you prefer. And we're going to need a local variable as well called lindex. Make sure that the default value for lindex is -1. Otherwise, you're going to have to put a boolean in here and run another branch afterwards to check and see if it is a valid index. Because if it is not a valid index, we're going to return this default value of -1. And that's going to determine our next step. So kind of up to you if you want to do that or not. Anyway, our find slot with space is going to take our inventory content. We're going to run it through a for each loop. And this could be pure. I'm not going to make it pure because it's very important. That's kind of how I decide on pure or impure. If it's really important, I won't make it pure. So we're going to break that. We're going to get the item info. Whoops. Get item info is just going to take this value coming in from the struct and get it. We're also going to break that. And we're going to need to check a few things here to make sure that we are getting the proper item. And that the slot actually has space. So there's going to be two things we're going to need to check here. First, we're going to need yet another custom function called getMaxStackSize. It's going to be AddItem. It's going to be pure. And I might actually put this... Yeah, I'll actually put this in the... Nah, we'll just leave it here. It's not a big deal. We could put this in the blueprint function library, but not a big deal. Because it's going to do that same thing that we've been doing with all the other ones that come in here. I'm going to get the data table row for the soft data. You get the item ID. Whoop. I'm going to break open the out row. And we're going to return. The stack size. If the row is not found, I guess we can just return -1. I don't think I'm ever actually going to use that as a checksum, but I guess if you maybe want to check and see if you actually have the item row, you can return -1 there. So we have that pure function, get max stack size, and we are going to take the item ID. We're going to see if max stack size is less than the quantity coming in, and stay with me here, and the item ID equals the item ID coming in, and the enhancement level equals the enhancement level coming in. Now, if you're not using enhancement levels, this won't matter too much. You don't really need to check and see if it's equal because nothing will be enhanced. But if you are using enhancement levels, this does matter a little bit, especially if you end up wanting to be able to stack things like swords later on. Like if you have a silver sword of enhancement level 1 and a silver sword of enhancement level 2, you don't want to get the stack size here and say, well, I can stack a level 2 sword on a level 1 sword. So you want to make sure that you're getting basically the exact item that you need out of this. Okay, so that's why we have these. So we're going to get the max stack size. We're going to see if the max stack size is less than the quantity, and the items match, and the enhancement levels match. So if the max stack size, if the item's quantity in the inventory is already at the max stack size, this will be false and fail, right? That way, because we can't add items to a full stack. Okay. And then we are just going to go ahead and return the local index. So we will promote this. We will set our local index here to the array index on true. And we will go ahead and return that. But I'm actually going to make this a for each with break. I didn't do this in my example project, but now that I'm looking at it, I can make this with a break, so I'll make it with a break. Again, kind of a personal preference for me. Just because once we found a slot that is valid, we no longer need to continue on here. So we don't need to loop through the entire inventory every single time we do this. We can just break out and say, okay, yeah, we found our slot. And if we didn't find our slot, this is going to run all the way through and return -1 for the local index, which is its default value, because it never got set anywhere. Okay. So that's that. And that is our find slot with space. So that's the first thing we're going to do here is find slot with space. And for the item info, again, we're going to pass in that item info that we are getting in at the start of the function. Now, like I said, we're going to need to check this, see if this is greater than or equal to 0. If it is, that means we found a valid index. And if it is not, we're going to have to run some other functionality. But first, let's see that we found the valid index. Okay, well, what do we want to do now? We want to add to stack. Add to stack. And that's going to be part of AddItem. And add to stack is going to do exactly what you think it is going to do. It's going to add the item to the stack. So we're going to take that index value. And we're going to take our amount. Although we don't really need amount, you could probably always have this as 1. Because I don't think I use this amount for anything else in this tutorial series. Or if you really wanted to, you could, add to stack, get the amount of space remaining for this index. You could run another one that gets the max stack size minus the quantity that it currently has to get the amount and pass that through. But we're just going to keep this simple and add it to the stack with an amount of 1 and the index that comes off of here. So that's true, right? If we found a slot with space, we're going to add 1 item to the stack. We're going to take our local remaining and we're going to decrement it. And that's going to subtract 1. And that's all we're going to do here. So let's go ahead and build this add to stack before we forget. Because all we're going to do for that is we're going to get inventory content. We're going to set the array element for the index. I'm going to break our item, or make our item, I should say. Whoop. And we're also going to take this and get a copy at the index. So this is going to get a copy of the item at the index we are changing the item from. We're going to break it open. And we're going to set our item ID. We're going to set our enhancement level because we know those are the same. And we are going to add 1 to our quantity. So we're going to say quantity plus amount. Again, if you're only ever using this for 1, you could just say add 1 and not pass an amount in, but it's not a big deal. We're just going to add that to the amount and go ahead and set the array element. That's all we're going to do here. So back to our add to inventory. We have added the stack and set the local remaining to subtracted 1. Okay. Off of our false here, which means we did not find a slot with space, we need to run another check. We need to see if the inventory is full. So I'm going to add another custom function. Oops. Is inventory full? It's going to take our inventory content. Let's get the length. Subtract 1. That way it handles 0. Let's see if that is greater than or equal to the inventory size. And we're just going to go ahead and return that. So, say be full. So if the inventory length minus 1 is greater than the inventory size or equal to the inventory size, then the inventory is full. If it is not, then the inventory is not full. That's going to be pure. And I'm actually just going to put this in the category of getters because we might use it later on. It's not exclusive to AddItem. I don't think I use it anywhere else, but you might need to use this later on. So back in our add to inventory, we're going to pull out that is inventory full. That's going to be our branch here. If our inventory is full, we need to fail. We can no longer add items to our inventory. So we're going to fail out. This should pretty much never happen because we're going to run conditional checks to make sure that we have enough inventory slots for all of the items that we're adding to our inventory. But we do want this condition here just in the off chance that we somehow messed something up. That way we don't have an infinite loop that crashes our game. Now you could also handle your overflow here. This is not the way in which I wanted to handle overflow, so that's just not what I'm going to do. but you could handle overflow here as well. Again, I'm not going to do that. We just want to fail out because we are using a while loop, and these are very, very, very picky. So we want to make sure we have a way to absolutely fail out. So on false, that means we have inventory slots available, right? Our inventory is not full. So we need another function. And that's going to be add new item. This is also going to be in the add item category. And this is also going to take in our inventory info structure as item info. And we don't need to give any outputs here because all this is going to do is take our inventory content and add an item to it. Because we know that we have space, so we can just go ahead and add it. So we're only adding one. Now, if we were trying to add more than one, we'd have to check like the max stack size, make sure that it's not a equipment, which can only be stacked once. But we're not doing any of that, right? Because we're using a while loop, so every single time it is only going to be adding one. So we're going to say add new item. We're going to make this. We can't just pass the item info directly in, otherwise the quantity will be broken. I'm going to break that. Take the item in ID, the enhancement level, and add a 1. Now it's going to create a new stack. Again, if you want to add conditional checks to see if it can be stacked and all that stuff to kind of trim this down. Ow, I just bit my tongue. To kind of trim this down a little bit, you can do that, but I really don't think it's necessary here. We're never going to be adding 50,000 items to the inventory at once. And even if we are, maybe a slight loading screen will handle that compute time for us. Okay, and that's all we're going to do here. That is our add to inventory. So I know we had to do quite a few things here. Let's go ahead and review. We're going to take in our item info. We're going to take in the amount of that item, so the quantity that we want to add to our inventory, and promote that to a local variable. And we're going to run a while loop. So while the local remaining is greater than 0, and the local fail has not been triggered, we're going to see if we can find a slot with inventory space. If we find a slot, we're going to add it to the stack and decrease the local remaining by 1. If that's false, if we did not find a slot with space, we need to make sure our inventory is not full. If our inventory is full, we're going to fail out. If our inventory is not full, we're going to take our item info, we're going to break it, and we're going to add a new item with 1 quantity and reduce our local remaining by 1. Okay. So I know we got a little sidetrack there, but that is add to item. Okay, so now I'm going to do a couple of things real quick to save our inventory. So we need to save and load our inventory from our player. So we're going to do that on event begin play. The first thing I'm going to do is run a branch. Use inventory size. If for whatever reason you don't want to use inventory size on your player, we're going to set our inventory size to 9 billion. And that's going to give it this, whatever this number is, that's the absolute maximum an integer can be in Unreal Engine. Okay. So we're going to do that if inventory, use inventory size is false. Now we need to run another check. We need to get the owner. And we need a way to see if this actor return value is the player without casting. You can cast here if you want to, or try to cast, or get the class and check and see if the class is your player class. I wanted to make it as easy as possible for anyone to be able to just drop this in. And I figured the way to do that was actually with tags. So we're going to go into our characters class defaults. Whatever player class you used here. Let's say tags, add a tag, and call it player. And we're going to need this in quite a few different places throughout our game. So just go ahead and keep that in mind. Add a tag to your player. That way it's set up as player. That way we can just search player. We don't need to cast. We don't need to have a hard reference to it. And we don't need to be confused or confuse anyone else who's trying to make the game as to which actor we're casting. Because maybe we end up with multiple different types of player classes for whatever reason, but they all have the tag player. So no matter what, this is going to get the actor with the tag player. And you'll see that this matters later on because the inventory component can be on multiple different items, like I said, vendors. So if it is not a player, we're not going to run this logic because it's a vendor, right? And the vendor is going to run its own load logic inside of its blueprint. But for the player, we're just going to add the loading and saving logic right here inside of the component. So we're going to get our valid save game ref. And we need to make some kind of values inside of our save game reference to save. Okay. Our blueprints, whoops, not blueprints. Go into our game, our save custom. And we need to add some variables here to control the player's inventory. So the first thing we need to add here is, whoops, not a local variable. Let's get out of that. Let's go back to the event graph so we don't mess this up. Let's add a variable here called inventory. And I'm going to set this to the category player inventory. That way I don't get confused, because we're also going to have values in here for the bank's inventory and all sorts of other stuff. Just like our inventory, this is going to be a type structure, inventory info, and it's going to be an array. I'm not going to worry about equipment right now, but we would also add equipment in here. We're going to add currency. Currency is also going to be in player inventory. And that's going to be a single integer. And we're going to add inventory size. And that is also going to be in player inventory. That way we don't get confused later on and have a bunch of other stuff. Because we are going to have inventory sizes on the bank as well. But we'll call that bank size. So I'm going to make a couple of functions here. The first one's going to be get player inventory values. And I'm just making this a function to kind of keep it a little bit cleaner. That way we don't have to just get all of these out manually. Kind of a personal preference thing. I'm just going to add the return. We're going to get the inventory, get the currency. Whoops, not set. Get. And get the inventory size. And we're going to just plug all of those right into this return node. Like so. So now inside of our player, or inside of our inventory, when we get this valid save game ref, we can just get player inventory values and go ahead and get them like that. And we are going to use those to set our current inventory content, our current currency. Later on, we'll do equipment here as well. But for now, we need to check one thing. We need to see if inventory size is greater than the default inventory size. And I'll explain in just a second. And if it is, we're going to set inventory size to inventory size. So why do we need to do that? Because when we load the game for the first time, the saved value is going to be 0. So if we load the game without actually having this conditional check here, it's going to be 0. There's not going to be any inventory size to give, so it's going to give the player a 0 inventory size. So we need to check and make sure that the inventory size that is saved is greater than the default value of the inventory size, and then set inventory size based on that. Now you could go in and say your save custom and make this like default 50, but that gets a little wonky. So we're just going to run this little conditional check here to make sure that inventory size has been saved as the proper default for the player before we actually set it. That way we don't reset it to 0. And if it is false, right, if the inventory size saved is not greater than inventory size, that means the player hasn't actually increased their inventory size yet, and we don't need to do anything. We can just carry on with our lives. And here we're actually going to run a conditional check later on for our equipment, but we don't need to do anything yet since we don't have equipment in the game. So that's all we're going to do. Basically, on event begin play, our component is going to load up all of the player data by itself, if it is the player. Okay? So inside of our player, we need to go ahead and add this component. So we're going to add AC inventory. Okay. And now we have the inventory component here. So I'm going to open up this setup tab. I'm going to say inventory size 50. And I'm going to check both of these boxes to use overflow and use inventory size. That's all we really need to do to set this up. Now the player will have access to this inventory component. Of course, we are going to need some ways to actually view the data inside of this. So let's go ahead and work a couple of those things out, and a way to save our inventory. That way we're actually saving the items when we pick them up. So up here, if you remember in our previous video, we set up the IGatherItem. And this is from our object here, our gathering node. We call IGatherItem when we pick up the item after we interact with it, right? As long as we can interact with it, we call this IGatherItem, which just takes the item inventory info and passes it through to the player. Okay? And since items by default, the gathering items have an enhancement level of 0, we can just leave that alone. So in our player, we're going to call this interface event. If you remember correctly, you open the interfaces. We're going to add inventory. That's the category we put it under. And just double click IGatherItem to get that event. So we need some other logic here inside of our player before we actually grab our AC inventory and add item. Or before we actually grab our AC player and add item to inventory, we're going to need to run some logic inside of our player. So I'm going to make a custom event, and we're going to call this GatherItem. And that's why we put an I in front of our interaction events, because if these were both GatherItem, it would stall out our engine. I guarantee it would, because that's what I did. So just be aware, that'll stall out your engine if you have them as the same name. If you did put them as the same name, go ahead and change the interaction event to I first. Just leave the lowercase of that I there and say IGatherItem, and then you're probably going to have to delete your save game cache and all of the superfluous details inside your project to get a good, clean refresh. Otherwise, it's going to keep stalling out your game because you have an interaction event with the same name as a custom event. You cannot do that. That's why I told you to put I before your interaction events. So on IGatherItem, we're going to gather the item. Did I spell gather wrong? Yeah, why does gather look so weird? It's such a weird word. I like to keep my interaction events kind of in their own bubble, separate from my actual player events. So I'm just going to move this over here, and we're going to gather the item. This is where I'm going to go for my AC inventory, add to inventory. We're going to go ahead and add that item to the inventory. Again, I'm doing this separate because we're going to have a bunch of other stuff. We're going to have our class manager seeing if we're using levels, and we're going to have that increasing our XP. But for now, we'll just add the item to our inventory, and we'll clear our interaction. We'll get a valid save game ref. And we will save the player inventory. So we're going to need a function inside of our inventory to do that. So we won't do that here, right? Player inventory, we can't do anything here. So we'll go into our inventory. We'll add a new function. You could do this inside of player if you really wanted to. But I'm just going to do it inside of inventory. Save player and alright, called save player inventory. Category is going to be save. And like I said earlier, this is going to this is going to get the actor, try to get the owner, get the actor hashtag player. That way, this, in case you do manage to call this somewhere that is not the player, it's not going to save it to the player's inventory. This is very important. Otherwise, you'll end up saving it to like the bank's inventory or the vendor's inventory or something else, I'm sure. So we're just going to call save player inventory and make sure that it is in fact the player. We get the valid save game ref. I'm going to set inventory. Oh, we have to make that. So, in our save custom, we only got the player inventory values. We need to set them. I'm going to call set inventory. And this can also be in player inventory. I don't think we use it anywhere other than player inventory. And set inventory is just going to do exactly what it says. It is going to set inventory, and it is going to set inventory size. If you wanted to also save currency here, you could, but we're going to save currency separately since it does other things. And we're going to have probably 3 or 4 different types of save game events inside of our actor component to do different things based on what we're doing in the game. So one's going to be save all inventory values. One's going to be save currency probably, and obviously we have save player inventory. And this is only going to save the player inventory, so that means nothing else has changed. We only picked up an item, so all we need to do is save the inventory here. I don't want that to say input pin. Yeah, make sure that says something descriptive like inventory size. And we're just taking inventory size every time, just for funsies. We could make another separate save that says set inventory size, but I think it's fine if we just pass it right through here in save inventory or set inventory. Now we need a condition check here, and I know we're not using this yet, but if you decide you want to have overflow, then you're going to want to take overflow, get your inventory overflow content, see if it is not empty. And again, we'll get to overflow eventually. We will use it, just probably not until much later in the series. This is just something I want to add in now since we added the values. It's kind of easy to add in now. Save. We're going to add a new custom function here called setOverflow. We're going to duplicate this inventory value, call it overflow. I'm going to add this to a category called overflow. And same thing here, we're going to add this to a category called overflow. And we're just going to set that. Actually, we're not going to do that. We're going to have 2 different functions in here. So later on, you'll see that we have one that will override overflow, but this one is not that one. Because the player does not always load overflow, we didn't load overflow anywhere inside of the player. This overflow is just going to be basically, inside of the inventory. This is kind of going to be conditional, so if there happen to be items in here, then we want to add them to the array of overflow items in the save game, not necessarily override the overflow array in the save game. We'll override it later, or I should say clear it later, when we actually pick up the overflow items. But that won't be until we do the bank system. So for now, we can just set overflow, and it just runs through the for each loop for all of the overflow items and adds them into overflow. So our AC inventory is going to get this save game ref here. Whoops. It's going to get this save game ref here and set overflow. I should have named it something like add to overflow. Get our inventory overflow. Do that. I'm going to route down here. And we're going to try to save the game. We're going to do an asynchronistic save here. It's totally up to you what you want to do. So anytime save player inventory gets called, we're going to make sure it's a valid player. If it is, we're going to set the inventory in the save game file, and we're going to set the overflow in the save game file if we use overflow and if overflow is not empty. And then we're going to try to save the game. So that happens in our player when we pick up an item. I don't actually need to get a valid save game ref here. We're just going to get our AC inventory and save player inventory. Now again, I could get AC inventory, I could have got inventory, content, got the size, got the overflow, and saved it all from here, but it's fine if we just do it straight from the component. A little bit cleaner that way. So for now, that's all we need inside of GatherItem. We are going to be adding a lot more stuff to this later on when we do classes, so we'll need to add experience to the classes. But for now, that's fine. So we're going to add the item there. That's going to save our inventory. So now when we start the game, we load the inventory. When we IGatherItem, we pick it up, we add it to the inventory, and we save the inventory. So I'm going to add a quick debug key here. We're going to call this key probably K. We're going to take our AC inventory. We're just going to get inventory content. I'm just going to loop through all of it. And add an event log. Break. Get the display name of it. Format the text. Let's say name amount. That way we have the display name and the amount printing into the event log. Just again a way to do that. And we should be good. Let's go ahead and press play. If I press 1 right now, nothing is happening. I pick up my 10 steel ore. Boom, we're going to see that the async game saved. Good. If I press 1, we're going to see amount steel ore, or name steel ore amount 1. Which it shouldn't actually be doing that. Silver ore amount 1. It looks like it's adding them all. Which is no bueno. We messed something up. Yeah, that is correct. No. Yeah, that makes sense. Our quantity needs to be less than the stack size, not the other way around. So that's probably what's failing this out. Let's go ahead and delete that, since that's like 99% chance what was failing this out. So when we get our max stack size inside of our find slot with space, it needs to be the quantity here needs to be less than the max stack size to return true. Not the other way around. We had the max stack size being less than the quantity, which was triggering it to be false. I should be able to pick this stuff up now, and it should be adding to the stacks. Yeah, it's adding to the stacks. So now if I press 1, whoops, Shift F1 for control, we see we have all of these little ones that are single amounts that we picked up on accident because we were checking it wrong. And then we have this one up top here, which is 11, and that's the one that it got added to. So we can pretty much pick these up indefinitely, and it's just going to keep adding them to the stacks we have. It's not going to say we have too much inventory. But if we were to add another one in here, so we were to add, whoop, we were to call you item ID, let's say 5, let's just say 7. And we're not going to do any cosmetics here, it's just to kind of test it out. Let's say this is item ID 7 of gold ore. Guess what? Our new inventory slot's needed, our inventory's full. So now we need to check a condition to see if we can pick up the item. It's one last thing I wanted to do before we log for this episode. I'm actually going to get my 2 key here. And we're going to use this to clear the inventory in just a minute. That way we can just clear out the inventory, since we have a bunch of 1s and stuff that I don't really like in there. And later on, we will work on a widget to actually get that stuff displayed. But for now, I'm going to keep that inventory full because I want to show what happens when we walk over a node, when we're trying to pick up a node and the inventory is full. So if you remember, inside of our component begin overlap on our capsule component, or however your interactions are handled, in our gathering node sequence here, we have our IGatherItem data, and we display the interact widget. Well, we don't actually want to display the interact widget if we can't pick up the item. Okay? Because right now, even though our inventory is full, we'll never be able to pick up this gold ore. Well, we can still interact with it, and we can still destroy it, but we're never actually adding that to our inventory. That's not really fair, right? So we're going to go ahead and handle that. Now, if you wanted to do the overflow, you could do the overflow here, but I don't want players to be able to interact with this if their inventory is full. Overflow is kind of like a one-off thing if an enemy drops an item, or if you have randomly spawning items that the player can just walk through and pick up in your game. That's what overflow is for, right? Not harvesting items. Or at least in my example, that's what overflow is for. So we are going to need to take our current interactable, the first thing we're going to do still is get the item data, but we're going to need to check and see if we have inventory space available to pick this item up from our AC inventory. So we are going to need a pretty complicated custom function in here called DoesInventoryHaveSpace. And this is going to do quite a few different things with some booleans. I'm sure there are multiple ways to do this, but this is just the way that I found was best. We have two input values here, so we have our name for our item ID and our quantity for the amount that we need to pick up. We're going to get our max stack size off of item ID. And we're going to check and see if that max stack size is equal to 1. If that max stack size is equal to 1, then this function's nice and easy. If it is not, we need to loop through a bunch of stuff and do a bunch of math. Okay. If this function is easy, if it is 1 item per stack, we're going to get our inventory content. We're going to get our length. We're going to subtract 1. And we're going to add our amount that is coming into this function. And we're going to see if inventory size we're going to see if this return value is less than or equal to our inventory size. Or you could say inventory size is greater than or equal to your inventory content minus 1 plus the amount. So this is going to take that amount. It's going to theoretically add it to our inventory content current size by getting the length and subtracting 1. And see if once the amount has been added to the inventory content, our inventory will be overfilled, right? If our inventory will be overfilled, then we do not have space. And if we have space, then we can go ahead and return true, right? We have space. So I'm going to add a return node here. This return node is just going to be a boolean. B has space. And if this is true, then we have the space. If this is not true, then we do not have the space. So you could actually not even branch here. You could just straight up return this value. Yeah, we don't actually need to branch here. So if your inventory content length minus 1 plus the amount of inventory you are trying to add is less than or equal to your inventory size, then you have space. If not, then you do not have space. So just know that that is how we are handling handle item with, or that cannot stack. So if the item stack size is only 1, it's nice and simple. All we have to do is see if we have enough space in our inventory to pile them all in. Now if not, we're going to have to do a bunch of gobbledygook. We're going to get our inventory content. I'm going to run a for each with break. So in our for each with break, we're going to break open our item info. We're going to see if our item ID that we passed in is equal to an existing item. If it is equal to an existing item, okay, we're going to branch. We're going to see if the max stack size, so we're going to get our item ID, max stack size. I guess it is get. We're going to get our max stack size, and we're going to see if this max stack size is equal to the quantity first. And if it is equal to the quantity, that means that this item is full. It's fully stacked. Okay? So we need to do some other stuff here. If it is not full, we're going to do something else. But let's go ahead and add a local variable real quick before we get carried away. And this is going to be local not found. So L not found. This means that we did not find the item in our inventory space. This is going to get set, I don't know why I put an apostrophe there. No, that's an L. I'm just blind. So this local not found is going to get set to true, right? If our item ID is not equal to the item ID. Or, I don't know why that branch got duplicated. Or if this is true, if we have a max stacked size of the item ID, we want to say that we did not find anything because the stack is full. Okay? So we want to act like we didn't find it at all because there's nothing we can do about a full stack. Now off of our false here, we are going to get the max stack size again. And we're going to see if the max stack size is greater than the quantity of the item that is currently in our inventory, right? The item that ID equals true, and the local amount that is being passed through our function here, just like we did up here. So we're going to take the amount of the item plus the quantity and see if our stack size is greater than that. We're going to run another branch, and that is off of our false here. So we found the item. The item is not full. Now we need to see if the item quantity that we currently have plus the amount that we're trying to bring in is greater than the max stack size. If it is greater than the max stack size, we need another local variable here, or a local bool here, called local available. We're going to set that local available to true here. And we're going to route down here. We're going to say local found, or not found, is going to be false off of here. So basically, local available will be false if this does not come up true. So if there is not enough space in this max stack size, we're going to need multiple slots to fill this, so it is not available. If it is available, that means we can throw all of the amount of the item that we are trying to pick up right into a stack that already exists. And then we're going to make sure that we set this to true because we did find, either way, right? Either way, we did find that we can pick up the item. Or that we probably can pick up the item, I should say. And we're going to break because now we can probably pick up that item. So inside of this break, things are going to get even more complicated. We're going to run a branch. We're going to run a return. We're going to need a bunch of return nodes here, because we're going to check and see if our inventory content length -1 is greater than or equal to our inventory size. So that is actually just does inventory, or yeah, not does, is inventory full. Yes. We should be able to just get inventory full and return. If we did not find, if local not found is true, we didn't find any available spaces that could possibly contain any amount of this item. And we're going to see if the inventory is full. If the inventory is full, then we don't have space. If the inventory is not full, then we don't have space. So this actually needs to be a not. Right? If the inventory is not full, then we have space. If the inventory is full, then we do not have space. So we're going to add a not here off of the local found. Now we need to check our available. So we're going to check our available. If available came up true, we're going to say we have space. Because, remember, that is off of this true, meaning our max stack size is greater than the total amount plus the quantity, so we can fit it all into a single existing slot, so it is available. Now if that is not true, if the local available comes up false, which happens, we are also going to need to check and see if our inventory is full, and return. Actually, it needs to be a not as well. So we're going to see if our inventory is not full and return. Because that means we found... Whoops. We found basically a slot that has some space, right? We found a slot that has some amount of space that is not full, but it is not enough... There's not enough space to fit all of the item in. And since our stack size here is generally 999, unless our quantity coming in is somehow over 999, then no matter what, we only need one slot, one additional slot in order to fulfill the requirements to pick up the item. So if you are picking up items that maybe you're picking up like 20,000 of an item for some reason, and your stack size is only 50, this is probably not going to work very well for you. This is going to fail, and probably do some bad stuff to your game. But if you are using the same game template I am making here, then you'll be perfectly fine. You're never going to pick up more items than can possibly be in a single stack. So basically this is just going to say that yes, we have an item available with a slot, and yes, we have enough inventory space because the inventory is not full to add an additional slot. If we cannot add an additional slot, then the inventory is full. This needs to fail out. Okay? So I know that's a little messy. If you have any comments or questions, let me know in the comments section. Let's go over it one more time. We're going to say, does inventory have space? This is going to take the item ID. It's going to get the max stack size. If the item can only be stacked to a value of 1, right? It cannot be stacked. It can only hold 1 of itself inside of the inventory. Then we're just going to see if the amount of the item coming in plus the current length of our inventory is less than or equal to inventory size. If it is, then we have space. If it is not, then we don't have space. We can't pick it up. Off of our false here, meaning that the inventory stack size is not equal to 1, that means in our project it is 999, or whatever you set it to inside of your data table, inside of the stack size value, right? So we have 1 and we have 999. I don't have anything in between. You might set it to 99 instead of 199, but either way, it's going to be your total maximum stack size. So off of the false there, we're going to loop through our inventory content and basically see if our item ID is equal to our item ID. So if we found one item in our inventory that is the same item ID we're trying to pass in through, then we're going to branch and check another condition. If not, we did not find the item, so we're going to set local not found to true. On that first branch, we're going to see if the max stack size is equal to the current quantity. That means if this comes up true, we're also going to set local not found to true because the current stack is totally full. It cannot hold any more items. Okay? So both of those are going to just set this local not found to true and continue on with their merry way. Now, if that is false, right, if it is not a full stack, we're going to continue through the loop here. So we're continuing through the loop. Anytime these fail, we're continuing through the loop. So these still have a chance to get passed, okay? If we run through the entire loop and both of these are still true, that's why it's our first conditional check, okay? So if that is true, right, or if that is false, if we are not full in the slot that we are looking at that has the item ID equal to the item ID already, then we're going to check and see if that slot can hold the entire amount that we are passing through this function. If that is true, then boom, we have an available slot. We are good to go. We can stop. If that is false, we don't want to do anything with available slot. You could set this to false if you wanted to, but we don't need to because it's false by default. So it's just not going to be set to true. So if it is false, we're just going to pass right through, and we're going to say local not found is now false, because now we have found a slot that can hold an amount of the item, and we're going to go ahead and stop, because we found it. We're good. We don't need to worry anymore. Okay? We don't need to keep cycling through everything. We need to take these last known values and go ahead and pass them. So if local available is true, that means we have a full amount, or we have a slot that can hold the full amount of the item, which is great. That's our number one guaranteed pass. If not, we're going to have to check some other logic to make sure we have a slot available. So on not found, if not found is true, that means we did not find a slot that can handle any amount of the item. We just need to see if the inventory is not full. If the inventory is not full, then it has space. If the inventory is full, then it does not have space. Okay? And that is because, like I said, we're never going to be picking up more than 999 of an item, more than the max stack size of an item at any given time. If you are going to be picking up more than the max stack size of an item, you're going to have to do something else here. You're going to have to do some more brain logic. Okay? So if that's false, right? If our not found is false, coming off of this, right? The only condition that is viable is if we did not have the max stack size of the item in here. Or if yeah, if we did not have the max, that's the only way. Then our local available is going to need to get checked. Okay, so if our local found is false, then our local available is going to get checked. Now, if this pops true, that's good. We have space. We don't have to worry about it because we have a slot that already contains the item, and all of the amount that we are trying to increase the item by can fit right into that slot. So we're good. Our available is true. We can pass. If it is not true, if it is false, that means we also need to see if the inventory is not full, because we are going to need an additional space to fit the remainder of the item. Okay? So we're going to just check that and see if the inventory is not full, just like we did up here. That means that we're going to add the amount later on into the available slot first, and then we're going to make a new slot for the remaining amount. Okay? All in our add to inventory. So again, if you have any questions, make sure to rewatch this part of the video. Leave them down in the comments. I'm sure there's probably a better way we could do that, but that's the way I did it. So, yeah. Back in our event overlap for our capsule component, when we are checking our gathering node, we're going to go ahead and get that. So we're going to see, does the inventory have enough space to actually pick up this item? And we're going to set that to our can interact. Actually, we're just going to run a condition, because we're going to need to do a bunch of other stuff later on to actually set this can interact. So first we're going to run a condition. Off of the false, we're going to add an event log. It says inventory is full. And that's going to set our current interaction, to false. So we cannot interact. And we're going to set our message to just inventory is full is fine. Now we don't necessarily need to do this. We can probably get away with not doing it, or the event log, but we're just going to go ahead and do both. So if I walk over this item and my inventory is full, it's not going to display the name of the item or anything like that. It's just going to say that my inventory is full. I'm not allowed to interact with this item. Off of the true, okay, we're going to have to do a bunch of different stuff later on, but for now we'll just set interact to true, and we'll go ahead and display the message. Because later on we're going to get our class data, and we're going to see if our class data is true, if we have the class available, if we have the levels we need to interact with it, right? Are we a high enough level to actually gather this item? We're going to do all that stuff later on. For now, we'll just set it to can interact true and go ahead and return the widget data. So let's check it out. And when I press play, when I try to walk over this gold, it's going to say inventory is full. When I walk over this iron, it's going to let me gather it. And that's because we have slots of steel, right, and slots of iron already in our inventory. So we have all these slots that can hold the item, but not with the gold here, right? We're going to say inventory is full because we can no longer pick up this gold. So now I'm actually going to use this key event here called 2, which is going to remove all that stuff from my inventory. Now if I press 1, it's not going to do anything, and I can pick up this gold. And I can pick up the steel. The new slot needed, new slot used, new slot needed, new slot used. Now if I press 1, I see that we have gold, silver, and steel, and an amount of 10. So it's properly stacking and adding to our inventory. And I can just keep picking these up forever and ever, and it'll just keep adding 10 until I hit the max stack size of 99. So let's make this 100. Let's make this 500. That way it rapidly fills up my inventory. I only made one 500, didn't I? Duh. And of course I made it the iron that respawns the slowest. So we're going to add 500 to that, sorry. 500 to the steel ore. No, we're just picking up 500. Now if I press 1, we're going to see that we have 540 steel ore. And as soon as that respawns, I'm going to pick it up again, and it should increase the stack. So now we'll have 2 stacks of steel ore. One should be 999. And the other one should be the remainder, which is 41. So, yeah. That is the basic idea behind how we're going to work with our inventory system moving forward. Thanks for watching. Hopefully I was able to explain everything properly for you. If you need to, remember, ask questions in the comments section. Go back and replay the video if you need to. And we'll all try to support each other as needed. In our next episode, we're going to go over the class component. So we're going to be making our classes and checking to see if the class is available and if the class has the level requirements available needed to actually harvest the item. So we're going to be doing that in the next video. So stay tuned. If you're enjoying the videos so far, I urge you to join our Patreon. For just $3 a month, you'll get access to all of the videos in this series as soon as I create them. Always available on Patreon, always free, and ready to go. You'll also get a copy of the example project so you can follow along step by step with a real visual guide in the project.